Today, we will be completing the IGCSE February to March paper of 2025, Variant 2-2, which is an extended math paper. I will be answering all the questions in the simplest way, explaining and showing working for each question. However, if you want a more in-depth understanding of a topic, make sure to check out my mathematics playlist. So, without further ado, let's begin. As we can see, this is a non-calculator paper, so a lot of our marks will come from our working. Question 1 asks us to calculate the cost of 9 kilograms of oranges in rupees. Given that we are told the cost of 1 kilogram of oranges, finding the answer is simply a case of multiplication. If we multiply 220 by 9 using this setup, we can conclude that it will cost 1,980 rupees for 9 kilograms of oranges. Question 2 tells us that Aryan goes on a journey, with the start and end times illustrated below, and we are asked to find how long the journey took. There are many ways we could solve this question, but I will show you two simple ways. The first method requires us to subtract the times from each other like this. Since 18 is smaller than 40, we will need to borrow an hour from the 14. Therefore, creating this equation. 78 minus 40 would be 38, and 13 minus 11 is 2, giving an answer of 2 hours and 38 minutes. Note that this method only works if the times are in 24-hour time. Alternatively, another method would be to convert both times into minutes by multiplying the first two numbers by 60, then adding the final two numbers. Thereafter, you would need to subtract the two numbers, then convert the final answer back to hours and minutes. While accurate, this method may be a little more time-consuming, so choose the best method for you. Question 3 asks us to identify a quadrilateral through clues of the shape. For clarity, a quadrilateral is any closed shape that has exactly 4 sides and 4 angles. There are about 7 distinct quadrilaterals: square, rectangle, parallelogram, rhombus, trapezium, isosceles trapezium, and kite. With the first clue, we can instantly rule out 5 of them, given that only a kite and an isosceles trapezium have one line of symmetry. However, with the second clue, we can also rule out the isosceles trapezium, given that its diagonals don't cross at 90 degrees. Therefore, the only quadrilateral left is the kite. Question 4 gives us an equation, and for part A, we are asked to find V, given M and P. This is a case of substitution, where M is equal to 10 and P is equal to -3. If we simplify this equation using multiplication and powers, we will get V to be 360. For part B, we are now asked to find the positive value of P, given V and M. To find this, we need to make P the subject of the formula, which will be something like this. Substituting both V and M and simplifying the equation will give us the square root of 400. Therefore, we should know that the only numbers that, when multiplied by itself gives 400, is positive and -20, and we should take the positive value, making P equal to 20. In question 5, we are asked to order these numbers in terms of size. The easiest way to do this is to convert all of the numbers to a common unit. In this case, I am going to convert them into the smallest unit, which is millimeters. For the first value, we should know that for every 1 meter, there are 1,000 millimeters. Therefore, if we times this number by 1,000, we will get 30 millimeters. For the second number, there are 10 millimeters in a centimeter. Therefore, we only times by 10, giving 29 millimeters. The third number can be left given it's already in millimeters. The fourth number is in kilometers, which may be a little difficult. If 1 meter has 1,000 millimeters, and 1 kilometer and 1,000 meters, we can conclude that 1 kilometer has 1,000 times 1,000 millimeters, which is 1,000,000 millimeters. Therefore, if we times this by 1,000,000, we will get 20 millimeters. Therefore, we now have to rearrange the values from smallest to largest. After that, do not forget to convert the numbers back to their original form. Question 6 asks us to find the area of this trapezium. From memory, we should know that the area of a trapezium is this. Therefore, taking 15 as A and 9 as B, we can substitute these values to find the area, which will be 96 square centimeters. Note that if you do not remember the formula for the area of a trapezium, you could simply divide the shape into a square and triangle and solve them separately. For question 7, we are asked to write down the inequality that is represented on the number line. Firstly, what we know for sure is that x is between -3 and 4. However, the dots on either side give us extra information. Whenever the dot is shaded, it shows that the number below it is included within the count, while unshaded dots show that the number below is excluded from the count. Therefore, the inequality should read that -3 is less than x, which is less or equal to 4. Question 8 shows us a probability table of a game in which one can win, lose, or draw. Part A asks us to complete the table. What we must know is that within a closed event, the total probability of every outcome has to be 1. Therefore, to find what the probability of drawing would be, we simply need to find the difference between 1 and the sum of the remaining probabilities. This will come out to be 0.45. In Part B, we are asked to find how many expected times Priyanka will win if she plays 120 times. If the probability that she wins is 0.3, then we simply have to multiply that with the number of times she plays, giving an answer of 36. Question 9 is asking us to solve this equation through estimations. As we should know, the first significant figure of a number is always the first non-zero digit within a number sequence. Therefore, for all these numbers, we must consider the next number after the first significant figure and determine whether it is greater than 5 or less than 5. If greater, we round up, while if less, we round down. Therefore, the numbers will read like this, and now we use our knowledge of the order of operations, starting with the exponent, then the multiple, then the division, and finally the square root, giving a final answer of 5. In question 10, we are given a very interesting problem pertaining to polygons. Given that this problem is worth 5 marks, we have to be very careful. In short, it tells us that 3 polygons converge at a point, with their interior angles being simplified to a ratio, and we are asked to show that this statement is true. The first thing we will need to do is decipher the ratio of each polygon. Since each angle is converged at a point, the ratio is split between 360 degrees, and therefore, we can calculate each angle ratio by taking the ratio of any polygon over the total sum of all ratios, multiplied by 360, giving us each angle respectively. Now that we have these angles, we have to find the number of sides polygons B and C have. To do this, we need to use the formula for interior angles, which is this. Note that n is the number of sides on the polygon, and we are further dividing by n because we only have a single interior angle. Therefore, if we substitute 120 and 150 respectively, we will find that polygon C has 12 sides, and polygon B has 6 sides, confirming the statement above. For question 11, we are told that a company sells items on both a website or in shops with a bar graph representing the sales. In Part A, we are told of the website sales in April and are asked to draw the graph of April. Since percentages go up to exactly 100, we simply need to find the product between the website sales and 100, giving us a value of 85%, and therefore, we can mark that on the graph. The remaining balance of 15% will be left unshaded, given that those were sales made in store. For Part B, we are told that in February, the company made $3.5 million worth of sales, and we are asked to work out the value of in-shop sales. As we can see on the graph, 40% of sales were made in the shops in February. Therefore, we can simply say 40% of 3.5 million. We can simplify the 40% to a fraction, then simplify it even further to get 2 over 5. This will be easier to solve in practice. Therefore, in the end, we will receive a final answer of 1.4 million. In Part C, we are given information about the performance of the company in May and June and are asked to find the percentage increase from those months. To solve this, we need to use the percentage increase formula, which is the difference of the two values over the original value multiplied by 100. This will give us an answer of 25%. In Part D, we are now given the total sales in 2024 and are asked to find the sales of the year 2023, given the percentage increase. This is simply a reverse of Part C, which we can write like this. Alternatively, since we know that the percentage difference between the 2 years will be 130, we could rearrange the equation to make this. Either way, we can simplify both equations to get a final answer of 40 million. For question 12, we are given a fraction equation, and in part A, we are asked to write a single fraction in its simplest form. As ever, we would start by finding the lowest common denominator of these three fractions, which would be 24. Now for each fraction, we will need to divide the denominator into 24, then multiply by the numerator, giving us these values. Then we would simply add common terms together to finally get this final form. For part B, we are given an expression and are asked to factorize it. The first thing that we can do is separate this expression into two forms like this. Now this part of the equation is already factorized, but this part requires further factorization. The term negative y is the common value in this equation, and therefore we can factorize this equation to be negative y multiplied by a plus 4y. Now if we put these expressions together, we find that the bracketed expressions are similar, and therefore we can factorize them once more, creating this final expression. Question 13 gives us a diagram of a cylinder and asks us to find the radius given specific conditions. It tells us that a sphere with a radius of 3 centimeters has an equal volume to that of the cylinder. Therefore, to find the radius of the cylinder, we simply need to equate the volume of the sphere to the volume of the cylinder. Luckily, within this paper, we have been given the formulas for volume of both shapes, so we will use those. First, by calculating the volume of the sphere, we will get a value of 36 pi. On the other hand, for the volume of the cylinder, we will have this. Therefore, we can simplify this equation to get the radius r to be 1.5 centimeters. For question 14, we are given a diagram of multiple angles. For part A, we are asked for the value of an angle plus reasoning. In order to solve these types of equations, we must be very careful in trying to identify as many angles as we can using the rules of circle theorem that we should know. There are about 8 different rules, but I will only explain the ones necessary. Other laws can be found on my math page. For part A, to solve for this angle, we must notice that this angle falls right inside a cyclic quadrilateral. This means that opposite angles add up to 180 degrees. Since its opposite is 110, then the angle in question is 70, with the reason given above. For part B, the questions ask us to find certain angles. In part 1, there are many ways one can decode the angle, but I will show you the easiest method. Firstly, just as we did in part A, we must notice that this angle falls within the cyclic quadrilateral, so therefore, we must find its opposite, which is this angle. In order to find this whole angle, we must first identify that these two angles appear on the same segment subtended by the same chord, and therefore, they are equal. We now know that this angle is 20 plus 45, which is 65. Therefore, since this is the opposite, we can subtract 65 from 180 to get this angle, which will be 115. However, this angle is a combination of two separate angles. We can solve this by identifying that this angle is part of a whole triangle, which, when deduced using the two known angles, gives a value of 50 degrees. Therefore, the angle we want is simply 115 minus 50, which will be 65. For part 2, we are asked to find this angle. From circle theorem, we can see that this angle is part of the triangle formed within the circle. Therefore, this angle between the tangent and triangle is equal to the opposite interior angle of the triangle, which we have discovered to be 65. Therefore, the answer to this angle is also 65. For question 15, we are given the coordinates of point A, and in part A, we are asked to find point B. Since this transformation is from B to A, we need to take the reverse of this direction, which would be -4 plus 5 and 1 plus 12, which would give the coordinates of B to be 1 and 13. For part B, we are given the coordinates of C, and we are asked to find the vector C, A. This is simply the case of finding the difference between both points, just like this. Once we operate properly, we should get a vector of -9 and 3. For part C, we are given properties of a vector and are asked a question. As you should know, these two lines represent a vector length, so therefore, we are asked to find the length of this vector. Since coordinates appear on a Cartesian plane, finding the length of a vector is achieved through making the line the hypotenuse of a right triangle, and therefore must be solved through the Pythagoras theorem. Therefore, since we know this expression to be true, we can take the square root of the squares of BA, then multiply it by 3. Therefore, we will get 3 times 13, which leaves our final answer to be 39. Question 16 gives us a stem and leaf diagram, and in part A, we are asked to find the interquartile range. For context, this is the range between the lower quartile, or 1/4, and the upper quartile, or 3/4. To find these quartiles, we can use these two formulas, where n is the total number of items, which is 13. This formula helps us to find where in the list the interquartile range will be. Therefore, if we substituted n to find the lower and upper quartiles, we would have these two numbers. For the lower quartile being 3.5, we would count 3.5 steps from the beginning. Therefore, the lower quartile will be halfway between 38 and 40, which will be 39. The same can be done for the upper quartile, which will be halfway between 51 and 52, which is 51.5. Thereafter, we will need to find the difference between these two values, which will make the final answer 12.5. For part B, we are given a scenario and are asked to find the probability that an event will occur. When faced with such a question, it is important to think of every possible outcome. Firstly, if 2 packets were chosen at random, this means that each packet must have been picked one after the other. This means that one packet was picked when there were 13 options, and another was picked when there were 12 options, given that the first one had already been picked. These are our denominators. Our numerators, however, will be the number of packets that are more than 50 grams and those that are less than 50 grams. These numbers can be interchangeable depending on what you have chosen to pick first. Secondly, because you could have picked any of the 2 packets first, we must multiply this probability by 2, since there are 2 ways in which the packets could be chosen. Therefore, if we do our calculations well, we will find that the final probability will be 6/13. In question 17, we are asked to work out this equation, giving our answer as a fraction in its simplest form. As we can see, we have a recurring decimal and a fraction that need to be added together. The easiest way to complete this problem is by converting the recurring number into a fraction. Firstly, we must understand that this recurring number means 0.2888 to infinity. Then, we need to equate this number to any unknown value, such as y. Our goal here is to find 2 variations of y that, when subtracted, they eliminate the recurring aspect of the number. Therefore, let's try multiplying both sides by 10. This gives us 2.8 recurring. This will not work, as the 2 will hinder the subtraction. Therefore, instead, we should multiply y by 100, giving us 28.8 recurring. If we choose to subtract these 2, we will have 26 being equal to 90y. Make y the subject, and we will get this fraction. Now we can simply add the 2 fractions normally, and when complete, we should have a simplified version that reads like this. For question 18, we are given a quadrilateral and are asked to solve the following questions. In part A, we are asked to show that CD is 10 centimeters long. In order to solve these types of questions, we first need to find a direction to come from. For me, the easiest path is using the Pythagoras theory on this triangle through calculating what BC is. This can be done by trigonometry of the first triangle, assuming we have memorized the core trig values. Since we have the angle and the hypotenuse, we can simply find AB, which is the asymptote, using this rule, where CAH is the suitable candidate. Cos 60, as we should know, is 1/2. Therefore, if we substitute and make A the substitute, we will get an answer of 9. Therefore, we can subtract that 9 from 17 to get BC, which is 8. Now, we can use Pythagoras to find DC, which, when calculated well, we will get 10 centimeters exactly. For part B, we are asked to find the perimeter of the quadrilateral, giving our answer in a specific form. Since we know most of the side lengths, the only other length we need is ED. This can be found through trigonometry of the first triangle, using the SOH rule. As we should know, sine of 60 equals this. Then we multiply it by 18 to get this as our answer. However, we must not forget to subtract 6 from our answer so that we get ED. Therefore, if we add all the perimeter lengths together, we will get a simplified answer of this, given in the required form. In question 19, we are asked to shade the required region on the Venn diagram. Firstly, it's asking us to identify the union of A, B, and C, which would be this whole region. However, since it asks us to find the complement, or the inverse of that region, what we shade is everything outside that region, which will look like this. Question 20 asks us to first simplify this equation. In its original state, it is very difficult to simplify without a calculator. Therefore, to solve this question, we would need to break down each value so that we can find common terms to add together. 300 can be written as 3 times 100, while 48 can be written as 3 times 16. Since these two are perfect squares, we can take both of them outside of the radical to make this equation. This is much simpler to add as the square roots are common, giving us this as our final answer. In part B, we are asked to simplify this value by rationalizing the denominator. In simpler terms, rationalizing the denominator means to remove the irrational or square-rooted number within the denominator. To do this, we would need to multiply both values by a single term that eliminates the root of the denominator. In this instance, this would be the conjugate of the denominator, which is simply the same exact term with the opposite operation in the middle. This method is exactly the same as multiplying by 1, as both the numerator and denominator are exactly the same. Therefore, through multiplication, we can multiply out both the numerator and denominator into this form. Notice how these two terms can be cancelled out, therefore leaving us with -3. Thereafter, we can simplify even further to finally get this as our answer. In question 21, we are asked to write down the coordinates in which this line crosses the y-axis. Whenever a point crosses the y-axis, the value of x is 0. Therefore, we can substitute x for 0 and therefore solve for y, giving us -3 as our y. In part B, we are asked to find the equation of the perpendicular bisector of AB. If this line were AB, then the line we are looking for looks like this. Firstly, the line crosses AB exactly in the middle, and secondly, the line crosses at a 90-degree angle. Therefore, the first thing we need to do is find the gradient of this line. This can be achieved through first finding the gradient of AB, which can be found using this equation. Inputting the values gives us a gradient of 2. Since we have the gradient of AB, we can now use this formula to the gradient of its perpendicular, taking m1 as our desired gradient and m2 as 2. Making m1 the subject gives it a gradient of -½ Now that we have the gradient of the line, what's remaining is to find the y-intercept. This can be done by finding the midpoint of AB, as that is the only point that is shared with AB. This is achieved by taking the mean of both x and y of AB, giving us coordinates 3, 11. Now that we have the midpoint, we can substitute it into the formula to find the y-intercept, which will simplify to 12.5, making our final answer this. Question 22 gives us an equation of a curve and one of its stationary points. In part A, we are asked to find the other stationary point. As we should know, one key idea of a stationary point is that its gradient will always be 0. Therefore, if we find the gradient of this curve and equate it to 0, we can find the x values of both stationary points, including the one already given to us. Therefore, to find the gradient, we will need to differentiate the equation. X cubed will be 3x squared, x squared will be 2x, and -x will be -1. Once we have this, we can now equate this equation to 0 and solve it using the quadratic equation. If unsure, you can find the equation on the front page of the paper. Once we substitute the terms and simplify, we will get two values. The first value is 1/3, which is the first stationary point. The second value is -1, which is the second stationary point. Therefore, we will need to substitute -1 into the initial equation to find the y value, which will be 1, and that is the final answer. For part B, the question asks us to sketch out the graph and determine whether this point is a maximum or minimum. The sketch doesn't need to be precise. Instead, it just needs to show the correct information. The first thing you will need to do is plot out the two stationary points. Simply just by positioning, we can obviously tell that this point will be the minimum and this point will be the maximum, given that this point is higher than the other. Alternatively, we could confirm our thinking by using the second derivative to determine whether the stationary point is a maximum or minimum. Either way, we can confidently draw out the graph and confirm that this point is a minimum value. For part C, we are told that this equation has fewer than 3 solutions. What this means is, if we were to take any horizontal line and call it k, we will find that it will not cross the curve at more than 3 points. Therefore, any horizontal that crosses the curve at fewer than 3 points will be in the range of k. Therefore, any line that enters this region will not be a suitable k value. So, in essence, we are looking for a range that falls in between these two ranges. For the top section, we can say that k is greater or equal to 1, as y equals 1 would give us 2 solutions. Anything higher would give us 1 solution. On the other side, we could say that k is less or equal to -5/27 for the same reason as before, and these would be our ranges. Finally, for question 23, we are given a term that we need to simplify. This requires us to understand basic rules of indices. Firstly, when a fraction is being powered, both the numerator and the denominator will receive the same power. Therefore, x squared to the power of 3/2 over 4 to the 3/2. 4 to the 3/2 simplifies to the square root of 4 to the power of 3, which will be 8. However, with this term, using the rule of indices, this is simply a multiplication of the powers, which will be x cubed, making this our final answer. For part B, we are asked to find the value of x through this equation. By itself, this equation is almost impossible to solve. Therefore, we will need to simplify it. The only way we can solve this is by using the multiplication law, where, if the bases of indices are the same, the powers can be added together. The most ideal base in this instance would be a base of 2, so therefore, we must convert each number to replicate that. 16 to the x is easy, as 16 is simply 2 to the 4, creating 2 to the 4x. Half to the x, using the negative indices, is simply 2 to the negative x. Finally, this term can be simplified to 2 to the 2 times x plus 3. Since all the bases are 2, we can create a new equation that reads like this. Now, after simplifying the equation and making x the subject, we can conclude that x is equal to 6.